Hello and welcome to the Daily Space. My name is Dr. Pamela Gay, and most weekdays the CosmoQuest team is here putting science in your brain. Today, however, is for Rocket Roundup, including this week, a rocket refusing to fly. Boeing's Starliner still isn't ready for its launch. Half of the 24 valves controlling propellant flow to the vehicle's thrusters malfunctioned, and the rocket was rolled back from the pad for analysis. Boeing restored functionality to 7 of those valves so far without yet figuring out the root cause of why they malfunctioned in the first place. But enough about Starliner. Let's get to the actual launches, shall we? First up, on August 4th at 11:01 UTC, the third Long March 6 rocket of the year took off from Haiyuan Satellite Launch Center in northern China and inserted a pair of Clio Connect beta spacecraft into orbit. Long March 6 is a next-generation Chinese rocket that uses less toxic kerosene and liquid oxygen propellant instead of the pretty but deadly combination of unsymmetrical dimethylhydrazine and nitrogen tetraoxide. As for the payload, the 2 satellites are development spacecraft for Clio Connect, a German company. These satellites are a test for a planned constellation to provide mobile communications. They operate in the Ka band, which is standard for satellites like these. A key part of their mission is to verify that the satellite transmissions will not be interfered with by signals coming from other communication satellites that are in much higher geostationary orbits. Interference could result in garbled or missing signals from both sets of communication satellites. Let's watch the launch. A secondary goal of Clio Connect Beta is to evaluate the performance of off-the-shelf electronic components in the satellite to see if they can be used instead of space-rated components. Off-the-shelf components are exactly what they sound like. Components that are ready-made, usually in mass quantities. This reduces the cost of building spacecraft because space-rated components are typically special ordered and very expensive. Now, from a small Chinese launcher to a much bigger one with a military payload. On August 5th at 1635 UTC, a Long March 3B Gen 3 rocket launched the ChinaSat 2E spacecraft to geostationary transfer orbit from the Sheshang Satellite Launch Center in China. Because ChinaSat 2E is a military communications satellite, not much is publicly known. We do know that it operates in the Ku band and has several steerable spot beam antennas, allowing communications from moving vehicles and secure uplinks. The rocket it launched from is a little more interesting. The Long March 3B is a 3-stage rocket with a hypergolic first and second stage and a cryogenic hydrogen third stage. Put differently, the first 2 stages were powered by the pretty but deadly combination of nitrogen tetraoxide and unsymmetrical dimethylhydrazine. These chemicals don't have to be kept super cold and are stable for long periods in storage. When they combine, they combust, resulting in a characteristically ominous and highly toxic reddish-orange flame and smoke plume on launch. The third stage, filled with a super cold liquid hydrogen, is much safer for people and the planet, but requires a lot of extra plumbing to keep the hydrogen under enough pressure and cold enough to remain a liquid. Let's watch the launch. after the break, I'll be back to tell you about a resupply mission to the International Space Station that just launched and some of the cargo it brought with it. Stay tuned. And now we go from the high orbit of ChinaSat 2E to the International Space Station. On August 10th at 2201 UTC, a Northrop Grumman Antares rocket launched from the NG-16 mission to the International Space Station from Pad 0A at the Mid-Atlantic Regional Spaceport in Virginia. In the tradition of naming the Cygnus spacecraft in memory of someone who has made a significant impact to spaceflight, the spacecraft was given the name SS Ellison Onzuka. He was selected as a NASA astronaut in 1978 and flew into space on Discovery's STS-51C mission in 1985, a classified mission for the Department of Defense. Onizuka was a crew member on the Space Shuttle Challenger that was lost in 1986. On board NG-16 is 3,723 kilograms of cargo to the station. That's 1,861 2-liter soda bottles of stuff, including equipment and science experiments. We don't have time to cover all of the experiments on board, so here are 3 that our team found interesting. The first is an experiment called Red Wire Regolith Print, a 3D printer designed to print with regolith, or the loose rock on a planetary body, like the moon. It consists of modified extruders and print beds for the 3D printer currently on the station. Printed samples will be returned to Earth for analysis, where they will be tested for strength and flexibility and compared to the standards for rigid plastics. The hope is that this technology will allow for construction of durable structures on planetary bodies. If future crewed missions could build shelter from materials already at their destination, they would be able to bring more science and food with them to their destination. Speaking of food, CRAPE, which is short for Kentucky Reentry Probe Experiment, is a proof of concept demonstration featuring 3 small capsules that were returned from space aboard the Cygnus. As the Cygnus burns up during reentry, the capsules will be released. Their mission is to record the conditions inside the capsules during reentry. Because the capsules are expected to end up somewhere in the middle of the Pacific Ocean, there is no practical way to retrieve data stored on board. Instead, the data will be transmitted back via Iridium satellites. If CRAPE is successful, it will pave the way for a new, relatively inexpensive way to return small payloads back from the International Space Station without having to dedicate a much larger return vehicle to them. Presumably, the next phase of CRAPE will be to figure out how to get the return capsules to the ground in one piece. And finally, the European Space Agency's blob. The blob is a slime mold. Slime molds are pretty neat. They do not fit neatly into the plant, animal, or fungi kingdoms. Composed of just one cell, it is still able to move, feed, organize itself into groups, and even transmit knowledge to other slime molds, all without a brain. In space, ESA astronaut Toma Pesky will monitor how a slime mold adapts to microgravity. Once Toma will monitor the slime mold for a period of time and record a time-lapse video of the blob. Using that video, students here on Earth will grow their own slime molds and compare their Earth blob's behavior to the space blob's behavior. After the break, I'll tell you about a satellite program that started almost 50 years ago and is still providing data that helps to inform about climate change. Stay tuned. This week in rocket history, the 50th anniversary of the launch of Landsat 1, the first satellite with the mission of observing the entire United States and the rest of Earth's land masses and monitoring changes over time. In case you missed it, the Intergovernmental Panel on Climate Change released its 6th assessment report earlier this week. in which the negative impact of humans on the Earth's climate has, unfortunately, been confirmed. The conclusions are based on many years of research and observations using data from many sources, including satellites like the Landsat satellites operated by the USGS. The Landsat program began with the launch of Earth Resource Technology Satellite 1, ERTS 1, which was renamed Landsat 1 upon reaching orbit. Built and operated by NASA on behalf of the U.S. Geological Survey, it launched on July 23, 1972, on a Delta 900 from Vandenberg Air Force Base. It was the first satellite with the mission of observing the entire United States and the rest of Earth's land masses over time. On board were two instruments, the return beam VidCom and multispectral scanner. Both were sensitive to visible and near infrared bands. The RBV recorded its information onto 70 millimeter black and white film, which was developed on orbit. In order to send the data back to Earth, the film was scanned with a process similar to how a television camera worked at the time. To give you an idea of size, 70 millimeter is the same size as the film used for an IMAX movie camera. The MSS used a 24 sensor digital detector in a whisk broom configuration, which collected data 1 pixel at a time by scanning back and forth across the image swath, meaning it could only capture part of an image in a diagonal fashion as the spacecraft's orbital motion carried it along and it scanned side to side. Unlike the RBV, which could capture an entire image in one exposure. Both instruments had a ground resolution of 80 meters, so it could see things that were just a little smaller than a football field. Unfortunately, the RBV failed before exhausting its film after taking less than 2,000 images. The MSS, on the other hand, operated until the spacecraft's data tape recorders failed in 1978, after which the satellite was decommissioned. That said, that wasn't the end of the program. Landsat 1 was just the first in a series of Earth observation satellites that continue to this day with Landsat 7 and 8. Landsat 2 and 3 were very similar to Landsat 1, though Landsat 3 included a thermal band in the multispectral scanner instrument used on the first two satellites. Landsat 4, which included an updated multispectral scanner instrument and a thematic mapper instrument, was operational from July 1982 to December 1993, about 5 years longer than expected. Its twin, Landsat 5, was launched in March 1984 and operated continuously for almost 30 years until it ceased operations in June 2013. Landsat 6 was launched in October 1993, but failed to reach orbit. It was similar to Landsat 5, but had an upgraded panchromatic imager called the Enhanced Thematic Mapper, which had a resolution of 15 meters. That resolution is good enough to see roads. Its replacement, Landsat 7, was launched in April 1999 and is still operational to this day, 22 years and going strong. Landsat 8 was launched in February 2013 and is still active. Landsat 9 is currently being integrated for launch next month on an Atlas V rocket. Imagery from all of the Landsat satellites is used by many different sectors, from agriculture, urban planning, forest management, precision agriculture, discovering new energy sources, and more. Landsat data is also used to monitor human health by doing things like monitoring mosquito breeding grounds or the health of plants using infrared measurements to identify areas affected by drought. Landsat can help water planning by informing managers where algal blooms might form. Algal blooms are harmful concentrations of cyanobacteria that can contaminate drinking water for humans as well as kill fish and other wildlife in the water. They create toxins that cause everything from headaches to reduced neurological, kidney, and liver function. It does this with its 30-meter resolution, which is capable of resolving 95% of all water sources in the U.S. It is also sensitive to the 620 nanometer wavelength the algal blooms reflect the most. The 40-odd year data set is also used to monitor glaciers and ice sheets to keep track of climate change. Landsat 8 images the entire Earth every 16 days, allowing scientists to track the movements of glaciers in near real time. The program is called the Global Land Ice Velocity Extraction Project, or GO LIVE. When Landsat data is combined with other datasets like atmospheric and ocean conditions, scientists can figure out what causes the ice sheets to move and how the movement will affect ocean levels. The large dataset spanning decades allows researchers to see changes over time and see if they're correlated to things like anthropogenic, that is, caused by humans, effects. Rather, it's human climate change. And guess what, folks? It's human climate change. After the break, we're going to bring you a little bit more joy, and we'll be back with this week's stat and facts. Stay tuned. To wrap things up, here's a running tally of a few spaceflight statistics for the current year. Toilets currently in space: 8. 4 installed on the International Space Station, 1 on the Crew Dragon, 1 on the Soyuz, 1 on the Shenzhou, and 1 on the Tianhe. Total 2021 orbital launch attempts: 76, including 4 failures. Total satellites from launches: 1,311. We keep track of orbital launches by where they launched from, also known as spaceport. Here's that breakdown. USA 28, China 28, Kazakhstan 6, Russia 6, New Zealand 4, French Guiana 2, India 1, Iran 1. And finally, your space fact for the week is related to the first Landsat satellite we told you about before the break. In 1976, a Canadian cartographer named Elizabeth A. Fleming identified using Landsat 1 data a previously unknown island located about 20 kilometers off the eastern coast of Canada, measuring just 25 meters by 45 meters. Its existence was confirmed by a Canadian hydrographic service by lowering Dr. Frank Hall Sr. from a helicopter. He never made it to the ground because he was attacked by a polar bear. He was quickly pulled to safety before the bear could take a chunk out of him. This island was thereafter designated Landsat Island after the satellite, and Canada grew by 68 square kilometers. This has been the Daily Space.